Hi, everybody, and welcome back to Cheatash. My name is Chris, and today we're going to be taking a look at Chapter 2 from the book Clean Code by Robert C. Martin. If you guys remember and had followed along last time when we discussed Chapter 1 from the book, it was just a brief introduction and what to expect from the book. And ultimately, from Chapter 1, the main message was that there's an art to clean code, and clean code should be something that is utilized by software development teams just to make things easier in the development process. And there was one principle from Chapter 1 which I thought was really nice, the Boy Scout principle, which was you leave your code base in a better position than it was when you first started it. And you want to make sure that when you are committing code, changing code, that you're always thinking of your other team members or other members, maybe not necessarily on your team, who are going to touch your code, and they need to be able to understand what is going on in the code. And that's really what clean code is about. How do you write code in a manner that makes it easy to understand, organize, has a clean structure to it, and overall conveys the message of what you're trying to do? Well, in Chapter 2, we're going to kick things off with how to do that, how to make your code cleaner. And one of the ways is using meaningful names, and meaningful names in all different spots of your code, whether it's variables, methods, classes, interfaces, etc. Using proper names helps to just convey the function or the main function of what that thing is going to be doing. And you don't want to have just something generic, which then makes you have to think harder about what the code base is actually trying to do. So Bob Martin, and actually this chapter is written by, I guess it's by a different guy, Tim Ottinger, Meaningful Names. I guess he wrote this chapter. But he starts off using intention-revealing names. So, as I was saying, names should reveal intent. If you find a better name, just change it. So if you find a variable right there, that's a JavaScript there, let D, and you come across this in your code base and you're wondering, well, what the hell does D mean? Well, maybe you should change that to have it be a little more explicit. Like, yes, you mean, when you write that code, you mean that D is going to be number of days. Well, why not just write that and use that as the variable name? So instead of saying let D, like I have there in the example, let number of days, let num of days. There's a rule, they actually mention it in this chapter. If you have to use comments to explain what things do, then you didn't really name it as descriptively as you could have. So yeah, I know from line 36 there that D is number of days by the comment, but really I could change around that name to be a little bit more descriptive. And as Tim says in this chapter, the name should answer all the big questions. And again, if it requires a comment, then it is not descriptive enough. So here's another example here. You have this method getThem. It's going to return a list of integer arrays. It's taking in a list of integer arrays. But what is this code exactly doing? I mean, we know that it's looping through the list that you pass in. And if the iteration within the list is equal to 4, then we're going to add it to a new list and return it. So if x at 0 is equal to 4, we're going to return it in this new list. But why is it doing that? And sure, this is simple code. Syntactically, it's correct, but implicit, we have to be a little more implicit or explicit in what it's actually doing. What is in the list? What's the significance of 4? What do we do with list 1? So this kind of looked a little bit better. And the example that they were trying to convey here is of something Minesweeper related. So was it Minesweeper related? Actually, I forget the exact context of this method, but essentially they rename it. Actually, I think it was Minesweeper related because you're passing in a list of integers with this game that's called game board. I believe that's what it was. So essentially this method and the previous method are the same, but this method is a little more descriptive. So instead of the previous method is being called, the name of the previous method is get them, this is get flagged cells. So I can already start to picture it. Okay, get them, I don't really know what we are trying to get, but in this method, getting flagged cells, get flagged cells. Okay, so we're returning flagged cells. So we want to get any flagged cells in the game board list, or in the list that's named game boards, and then we want to return that for some reason. So already this looks a lot better. And you can see there that instead of, when we're looping through and we're saying for int array x in the list, in this one we're saying, well, integer cell in game board. And I get it that this isn't like an exact apples to apples comparison. This is returning a list of integers, and the previous method was returning a list of primitive int array. But I just thought this was kind of just my own doing here. So we're looking for cells in the game board, and I can kind of picture it like a chessboard. Each square is a cell. We're looping through. If the cell is equal to flagged, well, what is flagged? I put 2 here, but this should be 4, just based on the previous example. We were checking if it's equal to 4 there. So maybe 4 would have been better to use here. But okay, so now we have some context. If the cell is equal to the number 4, that means it's flagged. If it's flagged, we want to return all those flagged cells. Looks way better. Continuing on, Tim talks about how you want to avoid disinformation. And what he means by that is that we don't want to obscure the meaning of code. So if something actually is a list, then it's appropriate to refer to it in the variable name as blank list. So if you have variables, like you have a variable account group, and then you have another variable account list. Account group might be a list, like an array list of strings or something like that. Maybe at that point in time, it would be appropriate to say, oh, account list instead of account group. But in other times, and I think we're going to talk about this in a couple slides, sometimes naming something as a list when it's initialized declared as a list is too redundant. So in other words, if I go back to the other previous slide, we have this list integer of flagged cells. It would be almost redundant to call it flagged cells list. This is actually a pretty good name, flagged cells. You don't really need the list part because a programmer is going to look at this and say, well, yeah, I know it's a list. That's what the type is, So, and then the last point there, using inconsistent spellings is disinformation as well. So inconsistent spellings, let me actually see what he wrote about this. Inconsistent spellings, I think like what he meant by this was, actually, I'm not exactly sure what he meant by it. Using inconsistent spellings is disinformation. Avoiding do not refer to a grouping of accounts as account list unless it's actually a list. Okay. And then if we continue forward, spelling similar concepts similarly is information. Using inconsistent spellings is disinformation. With modern Java environments, we enjoy automatic code completion with a few characters of a name and press of some hotkey combination. Oh, okay. Disinformative names. So this is like using the small case letter L which looks like a 1, probably not the best idea to use that because somebody could potentially get confused later on in the code, especially if you just use single letters, which we're going to talk about in a second. Single letter variables names are really good for things in a local scope, but not for things globally, where you have to keep in mind that you want to name things that are searchably friendly. Yeah, I just made up that word. Searchably friendly. So I think that's what he meant by using inconsistent spellings as disinformation. So next, make meaningful distinctions. You create problems when you write code solely to satisfy a compiler. So I do this a lot, actually, and maybe this means that I should stop doing this. Is that, yes, these two variables, name and name2, you're following camel casing. It's going to be a name. Now, is it a first name or a last name? Maybe you can be a little more specific. And, there's no compiler error here. These are two different variables, but they got to mean something different. You can't just stick a number at the end of a variable name and say, hey, this is different. Yes, you can do that. I've done that before, but you shouldn't write it to satisfy the compiler. You should write it for the programmer that's going to come back to your code base later. So if names are different, they must mean something different. Name must be something different than name too. Coincidentally, if you have, let's say, a product class, you have a class product which has product info and product data. This is kind of a similar thing. They kind of mean the same thing, and you would be best served by renaming them something different, distinguishing between them. And Tim calls these noise words. Info and data could potentially be interchangeable and mean the same thing, but you're writing your class in such a fashion as to distinguish between product info and product data. These are two different fields in your class, so the name should specify that. The name should exemplify that as well. These should be two different things. Product info could be renamed to, product description. Product data could mean, how about product sales? That way okay, this is a description of the product. These are the sales numbers of the products, just as an example. And same thing down there. Look at those three methods. You could be trying to convey three different things with those three separate methods. Get active account info, get active accounts. But somebody looks at that and they almost think, oh, wow, are they all returning the same data? They should be a little bit more meaningful, a little bit more descriptive. Continuing along, Tim talks about using pronounceable names. Pronounceable names. So not just using like a word salad. What's the word? The abbreviations here, which mean something. And we're going to talk about this, I think, in a couple slides. You don't want to have programmers mentally map. So if I look at string Yimid I don't want to have to mentally map that to somewhere else. So I don't want to have to translate that and map it to something else in order for that something else to then symbolize something in my brain. Also, it's just not pronounceable. How would you, if you're collaborating, you're on a Teams call with one of your coworkers, it could get confusing saying, oh yeah, we got to change Jen Yimid hymns and mod Yimid hymns. Use pronounceable names like the last two variables I have there. So generation timestamp, modification timestamp. And I think if you guys see there, generate GEN, and then the timestamp, the year, the month, the date, the hours, minutes, seconds. Yeah, generation timestamp. It's clear, concise, and then most importantly, or maybe not most importantly, but also very importantly, it is pronounceable. And using searchable names. So we touched on this just a little bit ago, and how much better it is on the right side screenshot, if you see there's a final int variable called flagged. How much easier that is going to be searchable, where I can just control find for flagged, and I can get, the couple of occurrences in the file, versus maybe on the left, if I had a final int x, right, equals 4, and I try to search for x, think about how many x's could potentially be in your class. Now, yeah, maybe you get lucky and you only have one. Cool. But why risk that? Especially if you have a huge file, which are some files I work in, are huge test files, and I search for a word and or a variable, and that variable is being used in every single test method, and it gets annoying trying to filter out for the exact occurrence that you want. So that's kind of why Tim advocates for using names that are unique, searchable, very searchable friendly. Again, single letter names should only be used in local methods. So that's why when you're looping, especially in for loops, you have for the initializer int I equals 0. Hey, that's totally cool. But, maybe for something like, again, on the right-hand side, final int I equals 4, it's probably to use a more distinct name for that, which is why we used flagged. So next, avoiding encodings. Avoiding encoding. So what are encodings? Encoding types are scope information into the name. So this is kind of, we talked about this a little bit earlier too, where you use the type in the variable name. So saying if you have a list of integers, you're going to call that variable integer list versus prime nums list. Well, this might be a little bit too redundant, too much information, because seemingly a programmer is going to know the type of the variable just from, you having it at the beginning of your line in the code, list integer, right? Like here, in my example, string, phone number string. People are going to know it's a string just by you declaring it a string. So you don't need to say phone number string at all. Plus, what happens if your phone number string, you want to change it, the type of it, and you change it from a string to a phone number type, and maybe you have a separate phone number class. Well, all of a sudden, your phone number string name is conveying some disinformation there because it's not a string anymore. It's of a type phone number. So that's kind of what Tim was getting at. There's this one naming convention that I don't think this is used anymore, and I hadn't heard about this until reading Chapter 2, was this Hungarian notation where you use prefixed letters to dictate a certain meaning. So for integers, you would put an I and then camel case, the variable name, or you would use str to convey it's a string and then the camel cased variable name. But again, in strongly typed languages, especially Java, I work a lot in Java, and we don't really see this a whole lot. I got to be honest, I didn't even hear about this Hungarian notation until reading this book. So it's the same thing with member prefixes. When you have fields, so variables that are a part of a class, like you have this class phone number, you don't really have to prefix it with an M to say that, oh, this M name is directly related to the phone number class. It's a member variable of the phone number class. You don't really need that anymore. And that's kind of Tim saying, well, that's something that's kind of redundant nowadays. So it'd be better off you just to name it private string name. But again, you could even refactor this a little bit and say, hey, private string first name, private string last name, because who knows? Somebody could see that private string name and think, oh, is that the first and last name combined? Or is that the name of a business? See, so there's different ways to break it down. I could have even refactored that a little bit there. Because, yeah, you don't really know what I mean there when I say name. So just something to think about. Something else to think about. Interfaces and implementations. Oops. So what about when you have an interface and you want to implement it in other places? Well, Tim says that there's some exceptions to the naming conventions that kind of we were just talking about. So if you're trying to build on an abstract factory, so a classic example, and shout out to ChatGPT for helping me out with the examples over here on the right. You have a shape factory where you want to create shapes. And it's an interface, which means that other classes are going to have to implement this. They're going to have to override the methods inside the shape factory interface, and they can kind of utilize it for whatever they want to. It's actually okay to name the implementation of shape factory simply shape factory implementation. So you say shape factory IMP, shape factory IMPL that I have there in the last bullet point. That's actually okay. Now, the name given here, circle factory, I'd say maybe that's even better, just based on everything that we've talked about earlier in this chapter, because it's super specific to say what exact shape you're going to be creating here. So you can have a circle factory. Then you can have a square factory. You can have a triangle factory. And when you override that create shape method from shape factory, you're returning a new square. You're returning a new triangle. So that might be a little bit better way of going about it. But Tim says simply adding the implementation suffix to it, not a bad idea. And actually, we do that a lot at work as well. I've seen that. So this is what I was talking about earlier, mental mapping. You don't want people to read your code and have to translate your names for things into other names for things in order to understand what they are. I shouldn't have put that question mark there, but it's the difference between being a smart and a professional programmer. And I spelled programmer wrong. Look at that. In the end, Tim says that clarity is the king over all things. So yes, you can look smart when you have complex, because maybe that's the two different ends of the spectrum here. You name things too simply, that's not good. But you name things too complex, well, that's not good either. And yeah, sure, you can come away looking smart, knowing that, this complicated variable name, Jen Yemidhims, is generation timestamp like we were talking about earlier. Or you can just be super clear and concise. And that's what being a professional programmer is all about, because it's not about you looking smart. It's about you leaving your code base in a better position than it was when you started, for the reason that other people are going to be looking at the code base, and you want to put them in a better position so that they're not running around like a chicken with their head cut off trying to figure out what other people wrote. So, continuing forward, class names. Yes, class names should be noun or noun-like phrases, avoiding verbs. So good class names are customer, account, car, house, circle, square. But you should kind of avoid words like processor, data, or info in your class names. You should avoid verbs in your class name. So a class called process data, we kind of want to avoid that. We want to save verbs for action things, or things that are doing something like, methods and functions, etc. Move list. Again, it has list in there. Move list. Move list. Oh, this is, again, using a verb, move list. We want to kind of, move list would be great. Maybe it needs a little more description, but it would be good for a method where maybe you're moving items from one list and putting it into another. But as far as a class name, it should be should be noun, something that's a noun or noun-like phrase. Noun-like phrase. But for method names are great. Use verbs for those method names. Now there's some rules when it comes to methods. You want to use things like get, set, is for your accessors, your mutators, your predicates. These are things within your class. So you have here in the person class, you have your getters, which you're accessing the fields in your class for use later on in your code base. You have getters, you have setters, which are your mutators. They're for setting your variables to certain things, and that way you can create objects within your code base. And then predicates, I actually never knew that this is what these were called. Predicates are like the things that are that return a Boolean value that you use to check if something's true or false. So in my person example, you check if somebody is an adult, so you call the is adult method as an example there. And then something else that Tim talks about is this concept of overloading constructors. So you can have constructors are basically how you can create a new object of that class. But you can have constructors that take in different fields from your class to create different objects. You could have a constructor, you'll see this on the left-hand screenshot. You have a private constructor there of a person, which is taking in a name and an age. You could have another default constructor, which is taking in nothing, and it's just a default constructor, no argument constructor. So it's going to create two different people with two different attributes, sets of attributes. The one is going to have a name and an age that you pass in, and the other one is not going to have those set. But what you can do, Tim says, is you can have methods, static factory methods within your class, which allow you to create a certain specific person. So you can here customize the method name and have it be very descriptive to the exact type of person that you're creating. So on the left-hand side, you see there's a static method that returns a person that's called create with name. And all you're doing is passing in the name, and it's going to have a default age of, I guess, 0 there. Somebody hasn't even been born yet, So this might be a better way of being explicit in your code base when you go to create a new person, a person object within your code. You can call the factory method so you would say person.create with name, because it's a static variable, so it's attached to the class. You don't have to create an object to call this method create with a name, and you're just going to pass in the name. Versus if you do the new variable and you say new person name, which I get it. Maybe me and you, we understand, okay, you're creating a new person with a name, but at least this way, maybe it makes it a little more explicit. This was a funny section. Don't be cute. So ultimately, Tim says you got to say what you mean and mean what you say. Say what you mean and mean what you say. And it's better to choose clarity over entertainment value of your variables, methods, what have you, classes. So you could have a method that's like holy hand grenade, which is funny, okay. But how about you just call that method delete items? You have a method called smash or maybe terminate's not actually a bad word, but yeah, like smash and grab. But why not just rename that close process, close shipment, something like that. Don't be cute with it. Just name the things that make the most sense. Say what you mean. and mean what you say. So coming up next here, picking one word per concept. And this is essentially Tim saying you have to use consistent lexicon in your code base. So if you use words like fetch, retrieve, and get as prefixes to some of your method names, well, why not just stick with one of those and reuse just one of those prefixes? Because you could say like fetch list, then you can have a retrieve list, and then you can have a get list. And maybe they're all doing the same exact function. So why not just pick one and just run with one? Any sort of retrieval of a list, I'm just going to call it fetch list. Right? And especially too, if you have 3 different methods all called these 3 different things, and they're in 3 different classes, well, how will you know which one goes with which class too? Ultimately, you should have consistent method names in each of your classes. If you're going to be getting, or if you're going to be writing, just have write da 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 da. Write da da da. Use that same naming convention, that same concept to iterate to your fellow programmers. Okay, this is used to post things to your database. We're going to prefix it with write. Write to DB. Write to such and such table. Write to such and such table. Also, I know it sounds hard, but don't pun. Having similarly named methods that provide different functions. Don't try to be punny. Actually, this isn't really what he meant by this, but you could have an add method that concatenates 2 strings together, but you can also have an add method that adds items to a list. So in this situation, you should consider renaming one of them. So, okay, maybe the add method concatenates strings, but then when you want to add items to a list, you have a method that's called insert to list. Something like that. And even specifically, you could say insert to numbers list. And that way you have different insert methods for different types of lists that you have, just as a thought. Solution versus problem domain. And this was an important concept. This is actually maybe the most important concept in this chapter. So there's these 2 domains, and Tim says that you want to use names that are within the solution domain. So you want, and what's the difference between solution and problem domain? Well, the solution domain is influenced by the technical components, like the design patterns, the algorithms, basically things that only the programmers would know. Now, the problem domain is derived from what you are trying to solve for, and it's from the aspect of the business. So think about it like that. Solution domain is the technical side. Problem domain is the business side. So when you're naming things from a solution, or when you're naming things, Tim says that you want to come at it from a solution-oriented domain. Because programmers are going to know when you name something user controller. You have a Spring Boot project. You have it annotated with the REST controller. They know what that controller is going to do. You can name something a user repository because they know the function of that user repository interface. When you name something just customer or invoice, which is good, and you're going to have classes and such that are named these things. You're going to have that. But this is more so to convey what your code base is doing for the business. And ultimately, I think what Tim is saying here is that, look, the business is going to understand how your app works from using it. And when you're writing the code, you are writing it for that end user to make it work, but you're also going to be writing it for other programmers who are going to understand the certain names that you use. Because ultimately, the business side is going to see the end product. They're not going to really see the underlying code under the hood. if you guys know what I mean. So whenever you name things, don't shy away from naming them from the solution domain side and being specific with those names. Last, and we are almost done here. Add meaningful context. Adding meaningful context. So this is kind of the example that we talked about earlier. How would you know if the variable name's first name, last name, street, state, form, and address? So that was like the previous example, or like the phone number example, where I had a string field, a private string name. Well, how do I know that that name is the first name or the last name? Or is it the name of the business? Or is it the name of a charity? Etc. So how do you get around certain things like that? Well, yeah, you could be specific. You could have a first name variable, last name variable. In this case, for street names, you could add context by adding a prefix ADDR. So you could say ADDR first name, ADDR last name, and so on and so forth. So they give this example of a method called print guess statistics. Now on the left-hand side, do we really know what's going on here? And you kind of have to read into it, and it takes a little bit of time, but you can kind of maybe guess what this method is exactly doing. So you're taking in a candidate. Okay, candidate, that might be like a person. You're taking a count. Okay, number. And then you have local variables, number, verb, and plural modifier. So, okay, depending on the count number, some conditional branching takes place and the variables change a little bit. And it's going to print a message there. So let's say if you have 0 count, there are no Chris's. So maybe candidate could be grocery store items, right? Something like that. It's just, do you see like the hoops that we kind of have to jump through to understand what is exactly going on in this method? And I'm not saying on the right side is perfect, but we kind of extrapolate this out into a class where we have this make method and we have a create plural dependent message parts method. And we take each of those conditional branches and we separate it out into its own method, which is just a void. And the local variables on the left-hand side become fields on the right-hand side. And all of a sudden you can kind of start to pick up on what the code is trying to do a little bit better. So when you call this make method, it's going to call create plural dependent message parts. So you're trying to construct a message. The message is going to be constructed based on how many letters there are. So if there's 0, 1, or a lot of letters, the message is going to change a little bit. So we get a little bit better of a description on the right-hand side than the left-hand side. And this was kind of a cool example that Tim had in this chapter on how you can really make things descriptive and use naming to your advantage to better convey your code to what have you, your coworkers, your team members, etc. And lastly, don't add gratuitous context. So it's like we talked about, I mentioned this earlier, not enough context in the name is bad. Too much context in the name, yeah, that's probably not great either. So shorter names are generally better than longer ones. And there is a gray area. There is a gray area, and I think you kind of got to go based on feel a little bit. If it sounds too long, it's probably long. If it sounds too short, it's probably pretty short. And again, when you prefix everything with the same letter, it makes it more difficult to find. So using that Hungarian notation, you prefix it with an I. Yeah, it might make things a little more explicit that this is an integer, but do you really need that I in front of your variable names? And in the end, naming's important. Naming requires very good descriptive skills, and it can be kind of a challenge. And you need some sort of shared cultural background when you name things, because look, I mean, we all come from different situations. Different names are going to mean different things to us. Like you say add, I think add 2 numbers, but you could mean like add something to your collection. You know, we're both right, but your life experience, my life experience are, I don't want to say interfering, but they're dictating like how we look at that word. And Tim says that this is essentially comes down to a teaching issue. And I think what he means is that, you know, hey, if we can all come together and just have mutual understandings about things, maybe teach others about like what's going on in our brain, and ultimately just come together on naming conventions for your project. And maybe some of these concepts that we talked about today are universal, but there's going to be maybe some instances where you want specific names just for your particular team, for your particular project. And I think it's important to talk about those things with your team within your project. And that's going to do it for today. Guys, thank you very much for listening. That was chapter 2 from the book Clean Code. Next time, we're going to be going over chapter 3, functions. That's going to be for next time, guys. It might be, that one might come out in 2 weeks. It might not be exactly a week from today, but it'll be out on the horizon very soon. I'll say that. And I appreciate you guys listening. Please like and share if you think this content is valuable. Let me know how I'm doing. And watch out for some more interviews coming on the Cheatash podcast. Some great guests coming up. That's going to do it for today. My name is Chris. This has been Cheatash. Take care, everybody.